Hello everyone, today I will present my IoT project, which is an LED remote control system based on IoT platform and the ESP8266 Wi-Fi model. The goal of this project is to build a complete Internet of Things communication system starting from a web interface connecting to a cloud platform and finally controlling a physical LED device remote using uh, a mobile phone. This project integrates web development, cloud communication, and embedding system control. This segment requires use to design a web-based IoT control system. We must use HTML to build the structures of the web page, CSS to design the interface layout, and JavaScript to implement the control logic. Most importantly, the LED must be controller remotely through a mobile phone, which means the system must support real close communication instead of local simulation. The system includes 5 major layers. First, the mobile browser as the user interface. Second, the web front-end built using HTML, CSS, and JavaScript. Third, the Anto IO Cloud platform as the data communication center. Fourth, the ESP8266 Wi-Fi model as the hardware controller. Finally, the LED as the output device. The control data flows from the mobile phone to the cloud platform via HTTP API. Then the ESP screen space to the cloud channel and update the LED state. The hardware setup includes ESP8266 LED resistor and the Wi-Fi network. The ESP8266 connects to Wi-Fi and MyTi's communication with the Anto IO server. When the cloud platform update the channel volume, ESP8266 reserve the after data and execute the digital write to change the GPIO output state, which control the LED. This demonstrate is the interaction between cloud computing and uh, embedded systems. On until I first create a thing named IoT LED. Then I create a uh, channel called tester, which is store LED control wallet. Next, I generate an API and API key and configure read write permissions. The API key is crucial because it ensures secure uh, automation uh, authentication when sending HTTP requests to the cloud platform. The image shows the channel created on the sync model of the Enter IO platform, as well as LR keys and the permission on the key model. HTML define the structural layout of a web application. The page contain a handle section, a status display, a real showing whether the LED is on or off, two control buttons, and a logic panel. This clean starter improves readability and makes the interface use user uh, friendly. CSS is uh, responsible for styling and visual effects. I implement gradient backgrounds or to create to a model UI appearance. The LED state dot change colors uh, dynamically depending on the state. I also add a animation Africa to make the LED indi indicator push then achieve. Additionally, response design ensure the interface to work uh, properly on model device. JavaScript is called logical layer of the system. It uh, it constructs API URLs using the API keys, sync name, and channel name. Then it used to use the fig function to send asynchronous HTTP request to the cloud. The system wait for a server's response and update the UI dynamically. This demonstrates uh, uh, asynchronous programming is a modern web application. The LED control function uses async and a way to handle uh, asynchronous communication. First, it builds the API URL using the channel sets endpoint. Then it sends a request to change the uh, one to 1 or 0. If the request is successful, the UI is altered immediately to reflect the new LED state. The ensure real-time interaction between user interface and the cloud system. Besides controlling the LED, the system can also read its current status from the cloud. The get requires the retrieve the latest volume story in channel. By passing the return volume, the web page determines very whether the LED is on or off. This ensures synchronization between hardware and the user interface. Now I will explain API standards used in this project. To write data to cloud, we use the endpoints channel sets. To read data from the cloud, we use channel get. The API URL include the API key, sync name, and the channel name. When volume is set to 1, LED is turned on. When the volume is set to 0, the LED turn off. This useful API starters makes communication simple and efficient. The ESP8266 acts as the hardware controller in this system. First, the connect Wi-Fi to using configures SSID and password. Then it connect to the IO cloud server. It subscribes to a specific channel and constant monitors update. Then a new volume is revised. The program checks whether the volume is 1 or 0. Based on the volume, it uses digital rights to change the GPIO output state. This completes the hardware response process. For mobile access, the web page can be deployed using Firebase hosting or live server. If live server, the model host must be connected to the same Wi-Fi network as the computer by entering the URL in the process. The user can remotely control LED. This demonstrates real remote access capability. Now let me explain the complete communication flows step by step. Then the user presses the on button on the mobile phone. JavaScript sends an HTTP request to enter IO cloud. The cloud platforms after the channel volume. ESP8266 continuously listen to the channel and data the updata volume. Then it changes the GPIO output state and turn the LED on. This completes one for IoT communication cycle. This video demonstrates. Oh wait. Okay. This video demonstrates the complete workflows of running the project. Let's see the video. Okay, we can see we open a web page in on mobile phone. We open the Enter IO cloud. Okay. The technical highlight of this project include cloud-based IoT control, asynchronous programming, and responsive UI design. The use of async and await ensure smooth communication without blocking the interface. The animate LED status indicate enhances user uh, integration, real-time uh, synchronization ensures consistency between hardware and user interface. This system demonstrates a real IoT cloud architecture instead of a local simulation. It supports remote control via mobile device. The frontends and the hardware are separate, which improves maintainability. The design is scalable and can be extended to multiple device or sensor. In calculation, this project successfully integrates web development, computing, and embedded systems. It demonstrates a complete IoT workflow from mobile user interface to physical hardware control. Through this project, gain, I gained practical experiences and in IoT, uh, tricky, 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 and real-time cloud communication. Okay, that is all my homework in this project. Thank you for your watching.